Welcome to our channel Circuits Analytica. In this video, we will discuss about network functions. In electrical engineering, a port refers to a point to which connections are made. Basically, there are two types of ports: input ports and output ports. For a network, if there is only one port, then it is called as a one-port network. And if there are two ports, then those networks are called as two-port networks. There are two parameters associated with a network: a voltage parameter and a current parameter. A network function is generally defined as a relationship between voltage or current parameter at different parts of a network. Network functions can be broadly classified as driving point function and transfer function. Driving point function is defined as the ratio of excitation applied to a port and resulting response at that port. Driving point impedance function Z, or ratio of response at a port and excitation applied at that port. Driving point admittance Y. For a single port network, driving point impedance function is defined as the ratio of voltage applied to resulting current. Z of S is equal to V of S divided by I of S. And for a single port network, driving point admittance function is defined as the ratio of current to applied voltage. Y of S is equal to I of S divided by V of S. In other words, Z of S is equal to 1 by Y of S and Y of S is equal to 1 by Z of S. For a two-port network, the voltage associated with the input port is denoted as V1 and the resulting current flow through the input ports is denoted as I1. Similarly, voltage associated with the output port is denoted as V2 and the resulting current is denoted as I2. The ratio of input voltage V1 to input current I1 is defined as driving point impedance at the input port Z11, and the ratio of input current I1 to input voltage V1 is defined as driving point admittance at the input, and it is denoted as Y11. Y11 is equal to I1 divided by V1. The ratio of output voltage V2 to output current I2 is defined as driving point impedance at the output port Z22. Z22 is equal to V2 divided by I2. Similarly, the ratio of output current to output voltage is defined as driving point admittance at the output and denoted as Y22. Y22 is equal to I2 divided by V2. Transfer function. For two-port networks, transfer function is generally defined as the ratio of voltage or current parameter at one port to voltage or current parameter at the other port. Based on the parameters selected, transfer function can be defined as voltage transfer function, current transfer function, transfer impedance function, and transfer admittance function. Voltage transfer function. The ratio of voltage at one port to voltage at the other port is defined as voltage transfer function and denoted as G of S. Current transfer function is defined as the ratio of current at one port to current at the other port. Transfer impedance function is defined as the ratio of voltage at one port to current at the other port. So transfer impedance function can be V1 divided by I2. It can also be denoted as V2 divided by I1. Transfer admittance function is defined as the ratio of current at one port to voltage at the other port. So transfer admittance function can be I1 divided by V2, ratio of input current to output voltage. Similarly, ratio of output current to input voltage is also transfer admittance function. Thanks for watching Circuits Analytica. Enjoy learning.